Hello students, myself Gunjan Mittal Roy in the Department of Electronics and Communication Engineering in Jamtech Greater Noida. This is my first video on my subject Digital Communication. This is the 5th semester subject in the Department of Communication Engineering. And the topic of this video is digital communication, where we have to cover analog to digital communication. So basically what we communicate in day-to-day life is the original signal which is acquired from the nature in its continuous form, in its continuous domain. This continuous form is called as the analog signal. So this signal, analog signal, is the conventional signal of communication, but this have a lot of drawbacks. There are so many drawbacks of communicating analog signal over long distances. So there is a need of digitization. So the conventional signal, if we are looking to transmit it to long distances, there will be a lot of problems such as distortion, interference and other losses, including the security issues. So these issues can be overcome if we digitize our analog signal. This digital signal will be more clear and accurate without any losses. So in the figure we can see there are two waveforms or two signals. The first one is showing you analog signal, whereas the second one is showing a digital signal. Our digital signal basically consists of high levels and low levels, which are represented by binary 1 and binary 0. So if we digitize a signal, there will be a lot of advantages. These advantages can be summarized as, first of all, the distortion, noise and interference will be much lesser compared to the conventional communication, which is analog communication. Second thing is, it will be more reliable in the sense that it will be having less interferences and it will be more accurate. We can trust on that data, we can trust on that information, so therefore it is more reliable. Third thing is that it is easy to design and it will be cheaper compared to the analog circuits. Then the hardware implementation will be more flexible and there will not be any crosstalk, or rather there will be rare amount of crosstalk. The signal remains unaltered or unchanged because the pulse needs a high disturbance to alter its properties. Then the signal processing functions such as encryption, compression, these can be employed easily in a digital signal. The probability of error occurrence will also be less. Spread spectrum technique can be used to avoid jamming. Time division multiplexing is more beneficial compared to frequency division multiplexing, which was used in conventional analog form of communication. And the configuration of digital signals is much easier than the analog signals. The digital signal can be saved and retrieved more conveniently than analog signals. Just like we know that the digital signals are stored in pen drives and hard disks, and these can be easily stored and retrieved, whereas the analog signals were used to be recorded in analog tapes, VHS, cassettes, so they were not very much convenient to retrieve and the quality was also not very good. Then many of the digital circuits have almost common encoding techniques and hence similar devices can be used for the number of purposes. The capacity of the channel is effectively utilized by digital signals. So there are so many advantages of having digital communication. That is why we are considering digital communication more beneficial, more effective than the analog communication. Now this is the basic block diagram of a digital communication system. In this block we have three basic sections. The upper section is called source, the middle section is the channel, and the lower section is the receiver section. If we start from the upper section, which is the source section, the very first thing is the input transducer or A to D converter. So it accepts the original signal in its analog form and converts it into the digital form. Then the second thing is source encoder. So basically source is a can be analog. For example, for a sound signal, a source is a microphone. Input transducer basically is a microphone which converts acoustic or non-electrical signal into electrical signal, and then it is digitized by using A to D conversion. Then comes is the source encoder. Basically it compresses the digital bits. It is always desired to have smallest or compressed signal so that it requires minimum bandwidth for its transmission. So it avoids or saves the redundancy or extra amount of bits, unnecessary bits, which are mainly zeros. Then comes is the channel encoder. The channel encoder basically deals with the problems related to error, such as error detection and error correction. For that, it uses the error detecting and correcting codes such as the parity checker, CRC, Hamming. These codes are used, and for these codes redundant bits are added. So the channel encoder adds redundancy, whereas source encoder reduces redundancy. Then is the digital modulator. Basically this is the device which converts analog signal into digital form, and the modulator basically digital modulator basically modulates the digital signal with the help of a carrier signal, and which is essentially a continuous analog signal. So basically the digital signal is converted into analog form, and this analog form is achieved in order to make the communication convenient over the transmission channel or medium. Then comes is the medium. Medium or channel can be of two types, wired or wireless, and this there are a number of wired mediums such as copper wire, twisted wire, optical fiber, and wireless such as the radio links, satellite links, terrestrial communication. So these are the different types of mediums or channels. Then digital demodulator. So the third main block of this system is the receiver section, and in this receiver section the very first block is digital demodulator. So it basically receives the analog signal and converts this into digital form. It reconstructs. Channel decoder detects the sequences and checks the error and does the error recovery. Then the source decoder. Source decoder basically again digitizes the signal by applying sampling and quantization, so that again a pure digital signal is obtained without any loss of information or quality. And the last output block is output transducer, which converts the electrical signal into its original physical or non-electrical form. And in case of a audio communication, a sound system, the actual form or physical form is the sound signal, which is received by using loudspeaker. So finally we get the output signal, which is again the sound signal. With this I would like to finish up my lecture or video on the A to D communication, A to D conversion on digital communication. Thank you so much.